if u is equal to sine inverse of x square plus y square divided by x plus y, prove that x into del u by del x plus y into del u by del y which is equal to tan into u. Previously we have to verify Euler's theorem, but here we have to prove that x into del u by del x plus y into del u by del y value which is equal to tan u. First consider the given problem. Here u is equal to sine inverse of x square plus y square divided by xy. To make the simplification easy, consider this value which is equal to z, which is equal to, if we take this sine inverse to the left hand side, that becomes sine u which is equal to x square plus y square divided by x plus y. This is a procedure to solve this type of problem. Here they have mentioned u is equal to sine inverse of x square plus y square by x plus y. Consider this equation as z, which is equal to, if we take sine inverse to the left hand side, that becomes sine u, which is equal to x square plus y square by x plus y as it is. Next step, we have to reduce this to the homogeneous equation form. For that, the procedure is same as before. Here, in the numerator, if we take x square as common, and in the denominator, if we take x as common, we get as x square into, the remaining is 1 plus, if we take x square common means you have to multiply and divide by x square. So we get as y by x whole square divided by, if we take x as common, the remaining is 1 plus, here simply y. So we have to multiply and divide by x, we get as y by x. Here x square by x we can cancel 1x, the remaining is x itself. So the equation reduced to the form x into, here numerator is of the form 1 plus y by x whole square, denominator is 1 plus y by x. So this is a function of the form y by x. We can simply write it as f of y by x, that is our sine u value. That is z which is equal to sine u which is equal to x into f of y by x. So we can conclude that this is a homogeneous function of degree 1. Here x power 1, so n value which is equal to 1. So we can conclude that this is a equation that is homogeneous function of degree 1. Next step, to prove that x into del u by del x plus y into del u by del y value which is equal to tan u. By Euler's theorem, we get the value as x into del z by del x plus y into del z by del y which is equal to n into z. This is because we are considering this equation value as z. So we have to apply Euler's theorem for the function z itself. So we get as x into del z by del x plus y into del z by del y value which is equal to n into z. This is our Euler's theorem. So we get, we substitute z value as this, that is z is nothing but sine u. Hence we can substitute the value as x into del of sine u by del x plus y into del of sine u by del y which is equal to, here n value is 1 into z is nothing but sine u. Understand carefully, we have considered this equation as z, so that z value which is equal to, if we take sine inverse to the left hand side, we get z value as sine u which is equal to this. So this is equation reduced to the form homogeneous function. So we have to consider the Euler's theorem for the function z. We get as x into del z by del x plus y into del z by del y which is equal to n into z, where our z is nothing but sine u. Substitute z value as sine u, here we get this. Next step, we have to differentiate this sine u with respect to x. Here also we have to differentiate this sine u with respect to y. We get the value as del u by del x and del u by del y, that is x into, here differentiation of sine u with respect to x is, here differentiation of sine u is cos u, into, again differentiation of u with respect to x is del u by del x plus y into, here differentiation of sine u with respect to y is cos u into differentiation of u with respect to y is del u by del y which is equal to sine u. Here also cos u term, here also cos u term. If we take cos u as common and that cos u goes to the right hand side, that becomes x into del u by del x plus y into del u by del y which is equal to, if we take cos u to the right hand side, that becomes divided by cos u, that is sine u by cos u. We know that sine u by cos u value is tan u. Hence we can prove that x into del u by del x plus y into del u by del y value which is equal to tan u. This completes the problem.